Hey there, and welcome back to another episode of CleanTechies, the podcast, Season 2, Episode 6, or if you're counting from the beginning, Episode 18. If you're watching on YouTube, please do comment your thoughts below after the show. Subscribe, hit the bell for notifications on future shows. And if you're listening on Apple Podcasts, please do give us 5 stars if you like the show, and share it with your friends. We're always trying to grow the show by sharing with people who might find these things interesting. So with that, I wanted to also remember to mention our sponsors, Next Wave Partners. So this show is sponsored and made possible by Next Wave Partners. And Next Wave Partners are a recruitment firm, a specialist recruitment firm that focuses on the renewable energy, infrastructure, ESG, climate tech, and technology recruitment businesses. So if you are looking to grow your team or take your career to the next step, please do reach out to Next Wave. You can reach out to them a few different ways. One is you can reach out to them by email at info@next-wavepartners.com. You can also reach out to one of their consultants that is within your remit by reaching out to them. You can go to their website to find who that might be. So you go to next-wavepartners.com and go under the team section, and you can find somebody who's in your space or covers your remit and reach out to them through there. And then with that, I guess let's get into the details of today's episode. So today I had the opportunity to speak with Jim Castelaz, the CTO and founder of Motiv Power Systems. So they're doing some pretty interesting stuff, and we had a really interesting conversation about commercial vehicles. Typically, specifically, small vehicles that do deliveries and typically don't go more than 100 miles in a day, kind of have a home base that they return to, and they've been in this space, electrifying these vehicles for quite some time. Actually, one of the first movers in the space, and just very interesting conversation with Jim. We talked about a number of other things too, such as talent retention and just the education system to help individuals to get into these careers, because I know it's not common that you find these specific types of careers within universities that they promote these items. So we talked about that as well, which was very interesting, but very interesting conversation generally with Jim. I hope you enjoyed as much as I did creating this, and without further ado, let's get into the show. All right, welcome to the show, Jim. Appreciate you coming. How are you doing today?
I'm doing well, Silas. Pleasure to be here with you. Thanks.
Absolutely. The pleasure is all mine. So I guess for everybody listening, why don't you just give yourself a quick introduction as to kind of who you are and how you got to where you are?
Sure. So I'm the founder and chief technology officer at Motiv Power Systems. I started the company about 12 years ago with our vision to free fleets from fossil fuel, right? And so the fleets we focus on are medium duty people and goods movers. So if you buy something off of Amazon, it's probably delivered more likely than not by some sort of medium duty delivery vehicle. A lot of kids get to school using a school bus that falls into our domain as well. So not long haul trucks, not passenger cars, but kind of everything in between. And, up until a few years ago, really, these fleets didn't have options if they wanted kind of energy independence, right? I mean, they really, their whole operations were dependent on fuel, and if they could buy fuel and for how much money. And, and I think we're really entering kind of a new era in transportation where there are alternatives to that now, and electrification is really taken hold, in passenger car and in this medium duty segment, and really enabled these fleets to look at what they do in a different lens and meet some of their sustainability goals in the process.
Okay. Yeah. Interesting. So I'm curious, how did you come across this? Because you founded the company. So what was the impetus for that? What led you to ultimately be passionate about the space and to create Motiv?
Yeah. So many years back, I was a grad student down the road at Stanford University, and there were some of my peers working on this solar car project, and then this startup called Tesla, right? And we saw Tesla and others startups focusing on electrification of passenger cars, and I thought that was pretty interesting. But it struck me that trucks and buses, use a lot more fuel, right? Probably 3/4 of the cost of a truck or a bus over its lifetime is its fuel. Passenger cars are maybe half and half. And it struck me that really we could make a big impact in energy independence and sustainability and climate change, looking at these larger vehicles, and that there weren't many people kind of working on them. And so, I kind of started Motiv with that vision of helping these fleets gain freedom from fossil fuel. And the medium duty space is a little different from passenger car because it's a bunch of small volume applications, right? You've got school buses, you've got parcel delivery vehicles, you've got bread trucks and beer trucks, and all of these other applications, and they're really tools to get a job done. And so while companies like Tesla were looking at the very high volume, the kind of Henry Ford Model T kind of space, right, where you can sell 1 million of them, the workhorses of our economy were kind of getting ignored. And so I took my electrical engineering background and applied it to that and tried to build some basic technology that was highly configurable for electrification of these vehicle platforms, where you really have a lot of different options and configurations that need to be dealt with.
So talk to me a little bit about the beginning when you started. This was what, 10, 12 years ago?
Yeah, about 12 years ago.
So what technologies, what was there that you were able to use as a base kind of starting point, and what did you have to really like develop, and maybe walk us through some of those kind of phases within the development of the company?
Yeah, so our first generation technology, we didn't even have connectors, right? There were no high voltage, high power connectors for these vehicles. So we ended up borrowing techniques from industrial systems like ring terminals and cable glands and such. And that's evolved over time. Now we can get connectors that move the power that we need. We can get orange cable, right? At one point, it was difficult to even get orange cable, which we use to signify, as a safety, indication. So, but I think what we've done historically at Motiv is leverage where the passenger car electrification movement has kind of gone first. And so like today, we use BMW i3 battery packs in our medium duty vehicles. So like these vehicles behind me here, like a school bus or a delivery truck, might use 3 of those packs. And so we're able to buy these great passenger car battery packs, but they're just not big enough for trucks, right? And they're not really designed to have 2 or 3 of them used on a vehicle. But working with the manufacturers, we've been able to figure out the hardware and software that's necessary to kind of do that integration and coordination, making sure they stay balanced and aren't parasitic to each other. So a lot of what we've done is the charge management and thermal management of these more complex systems, building on the building blocks that passenger cars have really brought to higher volume production.
Okay. Yeah, that makes sense. Obviously, it's tough when you're completely carving out a new space within, especially physical products and manufacturing. You can't just whip it up in a day. I'm curious, what you mentioned some sorts of the clients you work for. Could you walk us through more of maybe some specific use cases and kind of the types of vehicles you work with, and which ones are really you can really help out with their fleets, and which ones are not not the right fit at where you guys are at now?
Yeah, so that's a great question. So one of our customers, the largest parcel mover in Canada, is a company called Purolator. A lot of people in the U.S. don't know them as well, but they operate a lot of vehicles, right? And so we've been operating vehicles with Purolator, and the drivers provide the same feedback we hear from most of our drivers, which is once they go to electric, they don't want to go back, right? Especially if they're stopping 200 times a day to deliver packages or something like that. Everything about electric makes that easier. Their knee doesn't hurt from brakes. Their lower back pain goes away. They don't smell like diesel at the end of the day. They can actually hear their radio station because the vehicle isn't making noise, and they can hear safety vehicles and people around the vehicle too. So there are real safety implications as well. Another one of our customers, the largest linen delivery fleets in the U.S. are all our customers, and so. One thing that we've heard from linen delivery is sometimes their customers really want them to have a sustainable solution, right? The whole idea of linen delivery, you pick up the dirty linens, you launder them, or you return clean linens. It's actually kind of a cyclical economy and a very sustainable kind of business generally. And so it makes sense that they have been some of the leaders in adopting electric, sustainable green technology for their vehicles. And it doesn't hurt that they can now deliver linens to a hotel at 2 a.m. Without an idling diesel engine sitting outside somebody's window who's, calling down to the front desk to complain. So we find that generally customers or fleets generally that are doing local movement of people and goods, and so kind of return to base type of routes that are using their vehicles, their trucks or buses every day, because you want to use them every day because that's how you get the fuel savings and the cost savings. and they don't go more than, typically 100, 110 miles on a day. But you also don't want to only go 2 or 3 miles a day. Then you're not really saving much fuel. So, average 40, 50, 60, 70 miles, no more than 100 miles, and returning to a depot every night. Those are really great candidates for electrification. That technology is there today. You can go out and buy it from Motiv. You can buy it from other companies, and you can put them in your fleet, give it a try, see how it works. And if you're like, Pure Later and like Bimbo Bakeries, the world's largest bakery, they run a lot of our vehicles. Then you'll move through that pilot quickly and realize how much money you can save by going electric. And it's not just the money you save on fuel and maintenance, it's also knowing what your price of electricity is going to be. And we've actually had customers couple that with solar panels that they put on their facility with a long-term price purchase agreement, right? And so they lock in their price of fuel for the next 15 years, right? And so they have zero risk of fuel cost escalation, along with the fact that it's just so much less expensive.
Yeah, I mean, I think that that's a huge aspect, right? When you're planning, right, you can know the cost ahead of time, right? Because it is more sustainable. I'm curious, you mentioned range. So I grew up in a very, rural community. So I'm curious, what is the potential range for some of these things when, dealing with more, long-term, longer distance deliveries?
Yeah, so that's a really good point. I mean, I would say we're maybe 5 years behind passenger cars. You remember 5 years ago, you had your Nissan Leafs, which I drove a Nissan Leaf for a number of years, and 80 miles, maybe 100 miles. If you really push it, you're a good driver. It was kind of like what you expected with an electric car. And then we had Tesla and the Bolt and others coming out, and now it's 200 miles, 250 miles. And I would say most of the medium duty delivery vehicles are, including Motives, is kind of a range up to 100 miles today. Now, keep in mind that's with a payload of having two Teslas inside of the compartment, right? I mean, we're talking 8,000 pounds of payload. So, you're moving a lot of weight. And so that takes a lot of batteries. And with today's technology, we tend to say fleets focus on routes that are kind of under 100 miles if you want to be successful with electric. Next gen electric technology from Motiv and others in the next few years, I think will easily put that up to 150 miles. And with options, I think that we're seeing that will support 200 miles daily range. And for most of these vehicles, they're stopping 200 times a day anyway. So they can only do so many miles on their daily shift, right? A lot of times they're more limited by how much space do they have to store packages or how much weight can they put on the vehicle as well.
Yeah, that was actually I was kind of curious because the batteries are heavy. Is that typically kind of weighed out, no pun intended, when you're having a different motive of power?
Yeah, so the weight balance is a little different. You tend to be a little heavier on electric. The incremental versus diesel is small. The incremental versus gasoline is a bit larger. We see fleets either sometimes they just push up their gross vehicle weight rating, their GVWR. So they'll go, instead of a vehicle at like a class 5, 19,500 pound GVWR, maybe they'll go up to 22,000 pounds. And that extra 2,500 pounds, actually more than offsets the incremental battery weight. There are some applications where you're pushing up against a weight threshold. Like one of them is the 26,000 pound limit for commercial driver's licenses. And so many fleets want to stay under that 26,000 pounds because the driver licensing and certification is so much less burdensome. And so if they're really moving a lot of weight and they're hitting that limit, then yeah, they might see a payload impact. But other customers of ours, like Bimbo Bakeries, they're delivering air mostly, right? It's bread and chips. So
Exactly.
they typically cube out before they weigh out. And you can fit a lot of chips and bread on an electric truck. Yeah.
Yeah, that makes sense. I think it's typically probably not a big issue for a lot of the uses. So that's interesting. I'm curious, could you, maybe share a bit of stats regarding, these smaller commercial vehicles and what their emissions contributions are to the global emissions?
Yeah. So, I think when you look at this medium duty vehicle space, there aren't as many of them as passenger cars, so maybe 500,000 annually, but they disproportionately produce greenhouse gases because, not only are they producing a lot more emissions per mile, but they're doing a lot more mileage in a given year versus your average passenger car. And so we find that the offset, there's a little calculator on our website, if you go to motivps.com, where you can actually look at the offset kind of per vehicle, and it does vary a little bit depending on where you're getting your electricity. If you're somewhere like California, where it's a very green grid, your tailpipe emission savings are almost equal to your overall kind of wells to wheel greenhouse gas savings. Other parts of the country where you have more of a coal-fired grid, you maybe only get half of the benefit as you would in a place in California, but you still do get a benefit. Argonne National Labs has great tools for looking into the details of wells to wheel efficiency as well. And we've yet to find a case where an electric vehicle produces more greenhouse gas emissions. Maybe it's theoretically possible, but even with coal plants, you come out ahead.
Yeah, that makes sense. I think that's kind of, it maybe brings up the question with your suppliers. I'm assuming over the 10-year period, you've probably seen a shift in those. What have you guys been doing to try to ensure that you're getting supplies from the most sustainable focused companies? Have you seen an apprehension to doing that? And have you seen maybe more adoption in recent years? I'm just really curious because I know a lot of people talk about, oh, great, that's great in principle, but what about the supply chain? Where's it coming from? What's that happening? Could you talk a little bit about that?
Yeah, the electric vehicle supply chain has matured a lot in the last 5 years in particular. And, batteries are historically a big item to discuss, right? So end of life of batteries, with something like the battery packs we use today from BMW, they actually take those back and break them down and recycle the metals and what they can, and and are able to kind of even reuse some of the chemicals in the batteries. There are companies that do battery recycling too, which is kind of an interesting process. They essentially freeze the entire battery in liquid nitrogen and shred it, and then they can separate the metals. And so there are ways to kind of sustainably recapture a lot of the valuable, kind of material content in the battery in particular. What we find is the rest of the vehicle tends to last. You have very few moving parts, so your service life on these, which was already long, right? Already these medium duty vehicles are 12 plus years service life, so you can push that up even further. And maybe you have to do a retrofit of new battery packs depending on the kind of total mileage on the vehicle, or maybe you don't. But generally, we have seen that the supply chain has moved more towards a model of thinking through these end of life implications and cradle to cradle, as we say, with the parts that are going into these vehicles. And so, how do we remanufacture, reuse them? And there are applications for second life too, with moving. We haven't seen too much to date as an industry of using vehicle battery packs in applications like stationary energy storage. But I think that's largely because battery pack costs have been coming down so precipitously over the last 5 years that the economics tend to work better to just buy a new pack for stationary storage. But as battery costs inevitably level out, we're at under $200 per kilowatt hour now, and we'll get to under $100 per kilowatt hour at some point as an industry, right? But we're not going to get to zero. And so as those costs inevitably level out, looking at residual values of batteries and second use applications becomes much more economical. So I think we'll actually see more of that over the next decade.
Yeah, that's interesting. I think that the cradle to cradle mindset is something that seems to be taking off a lot. So that's interesting to see that there's already a lot of things being done there.
Mm-hmm.
What does the process look like when you're working with a new client, right? They've agreed to engage Motive Power Systems to change out their fleet. What does the process look like? What does the timeline look like? Could you walk us through that? And then, after that, we'll get into the cost of implementation.
Sure. So, I think the first and sometimes the hardest and biggest step for a fleet is just to kind of gain that realization that electric is real and out there, and that it's worth investing a little bit of their time and learning about. Right. And I think we see more and more fleets reaching that point, and it sometimes is pushed by sustainability mandates. Sometimes it's pushed by recognition that the regulators are coming, right? And the Advanced Clean Truck Law in California, with an MOU for 14 other states, is going to require adoption of electrification. But I think once fleets kind of realize that that electric is worth spending a little bit of time on, they quickly learn that it can really be a way that they can also achieve some cost savings and kind of also reduce the uncertainty in their operating budget. And so where we start, we have a number of considerations. We did a white paper on kind of 8 considerations for electrification on our website, but we oftentimes start with the vehicle, right, and how they use their vehicles. And we want to make sure that they have identified vehicles that are going to be a good fit for electric. So, they've got the volume and the weight, and the mileage makes sense for what an electric vehicle can accomplish, right? And then we'll look at where those vehicles are domiciled. Medium duty trucks usually spend 8 or more hours per day parked somewhere, like overnight, typically when they're not being used. Most of these vehicles are single shift operation. Some, like airport shuttles, are more like 20 hours per day usage, but most of them tend to be parked at a depot where they're being loaded, unloaded, cleaned, sitting there for 8+ hours. And so we want to evaluate that depot. That's the best candidate for where to recharge these vehicles, right? Because ideally you want to recharge a vehicle with a long dwell time, 8+ hours. And the reason why that's good is, for one, that's less stress on the battery. The longer you have to charge the vehicle, the less stressful it is on the battery. And that will prolong vehicle life. It will also reduce your charge costs from your utility. So you need to install less infrastructure and pay less, demand charge and other penalty premiums, versus if you charge on kind of a very spiky use case where you charge the vehicle very quickly and then that infrastructure is unused for the rest of the hours in the day. That would be an inefficient use of infrastructure. So we want to work with the fleet about charging. And typically fleets want to pilot electric trucks first. They want to try them because it is a bit of a paradigm shift, right? You've got this vehicle that's now kind of a computer on wheels. You need to plug it in every night, kind of like your cell phone. All the complexities in the software, right? And we download new software feature functionality to the vehicle. It takes some getting used to, and they want to see how it works. Like, can it really do the job in their applications and their fleet? And so we've actually developed what we call our quick start package, which is good for a pilot in one depot where they want to deploy kind of 2 to 5 vehicles in a single depot. And what we'll do then is, after kind of identifying the routes and how these vehicles are going to be used and what body style they need, like, is this a step-in van or a box truck, or maybe it's a bus, maybe it's a school bus, and we do a pilot with a school district. We kind of work with them to make sure the vehicle gets specified correctly. And then, knowing how many hours they have to charge and their average route length, we can right size the infrastructure. Because if they're doing 5 vehicles and they just put in 5 charge stations at 20 kilowatts each, because that's the most that the onboard charger can accept, right? They're probably oversizing. They could be paying 2 to 5 times more for the infrastructure than they need to be. And so with our quick start package, we'll evaluate that. And oftentimes we don't need a major upgrade from the utility. They don't need a new transformer. They can run 2 to 5 vehicles on typical routes that they're doing every day without a major power upgrade to their facility. And so that enables a really kind of low barrier to entry. They're not dropping new transformers. We can get those charge stations installed quickly. And we can kind of wrap that whole package together for the fleet and allow them to pilot these vehicles. And once that goes well, which typically, as soon as you get the driver behind the wheel, then it goes well, because the drivers like these vehicles, right? Then we talk to them more about, well, what does it look like to put 50 vehicles in a depot, right? If they're a larger fleet, or maybe we want to do pilots in 5 other depots, right? And try different regions and learn how these vehicles run in the cold, right? We have a cold weather prep package, which is pretty important if you're running these vehicles in Michigan winters, as we've learned, because we want to invest a little bit extra in insulation and the right heating systems to be able to efficiently keep the driver comfortable in the winter. And so we work with fleets through those larger deployment issues where maybe they do need to drop a new transformer, but let's make sure it's the right size of transformer. And let's look at how you're using that infrastructure when the vehicles are gone. Do you want to use that infrastructure for solar panels or stationary storage and backup to provide a little bit of blackout resiliency for your facility, right? And so what emerges is really what I see as the depot of the future, right? Where you've got electric trucks that are assets. They're assets when they're moving, delivering product, but they're also assets when they're sitting at the depot, providing energy services alongside solar and maybe stationary storage, right? And so, this really kind of turns every fleet into an energy management company. And that's a bit of a paradigm shift, but I think it really opens up a lot of opportunities for fleets to kind of think through what their operations are going to look like in 5 to 10 years, and how these electric trucks, can really be optimized for their use case as a fleet.
Yeah, I mean that's very interesting. I think that's a very thorough process, and it sounds like you've obviously developed that over probably a number of objections, right? And have developed this to be a relatively smooth process. Now I'm really curious to know what does it really come out to in terms of the return on investment? Because I'm assuming that there's definitely a strong incentive to do this on a fleet wide, deployment aside from just environmental reasons.
Yeah, so oftentimes for the initial pilots, we work with the fleet to identify incentive funding, which is great because a lot of time, because without incentive funding, these electric trucks, they are positive payback. They do have a total cost of ownership that's less than internal combustion, but the payback period can be kind of long. It can be 5, 7, 10 years, depending on their route profile and use case. And so to convince fleets that they should make a long-term investment like that, that's one of the primary goals of the pilot. And so states like California and New York and other states have incentives for these fleets to try out electric vehicles. Once they're ready to go to scale, then we bring in financing tools like vehicle leasing, and other kind of tools like that that enable fleets to kind of get comfortable with a longer payback period. And in exchange for that, they get a lot of certainty in their operating costs, and they get the sustainability, the driver benefits, of going electric. And so it's kind of where the industry is. I think we'll see in the very near term that costs are coming down, right? With maybe the exception of this past year and all of the automotive supply chain issues. Generally speaking, the costs of electric vehicles are coming down dramatically, passenger car and medium duty truck. And so we're going to see more applications become open to electric, economically speaking, even than what are today, as the vehicles can do more daily mileage and the costs come down as well. But even today, we find that the vehicles have a positive total cost of ownership. It's just sometimes a longer payback depending on the use case.
Yeah, that's interesting. I think that's an objection a lot of people say, oh, they're not really profitable unless there's credits, right? But I think that ultimately we have to think about it from perspective of we haven't even refined all the technology and it's still positive, right? So
Yeah.
imagine what it can be once you adopt it and then you have more opportunity for refinement. I also think that was very interesting. You mentioned the depot of the future. That sounds really cool. But I think that it shouldn't be overlooked, right? I mean, you mentioned the resilience with the power grid. Could you talk about maybe some of the other fringe benefits of this, implementing this for the businesses besides just the fleet?
Yeah, I think when we look at a depot of the future, it's an energy depot, right? And we're looking at consumption and use of energy. And so, marrying electric trucks with solar cells, solar panels is one of my favorite matches, right? Because then you're literally running your trucks on sunshine, right? Who doesn't like that idea? And then I think if you throw in stationary storage, right, you can kind of optimize your infrastructure use there, and you're able to maybe put power back onto the grid during peak demand. You charge your vehicles during the most off-peak hours, right? And then you're using the solar to run your facility, right? And you can do this all through kind of the same infrastructure, which makes it pretty attractive. And then if you're maybe you have seasonality issues with your business, right? And oftentimes the energy market is a way to buffer seasonality. And so whether that means during, with parcel delivery, you're putting a couple extra batteries that the rest of the year are stationary storage, go on your vehicle during peak season, right? So that you get the extra range during peak season. Or maybe you're a school district and during the summer, all of your vehicles are parked. Well, provide some ancillary services over the summer back to the grid when the grid needs them most. Things like frequency regulation and bidding into the hour ahead market to kind of stabilize the energy market, right? And so there are lots of opportunities kind of looking towards the future to kind of what a depot can do, and seeing these depots of the future as assets to our power grid rather than liabilities.
And just curious for people listening who are maybe interested in that, and it can be a complex topic. Do you guys have partnerships with companies that can help those people, your clients, to take advantage of those things?
Yeah. So right now, Motive is we can provide just the truck, or we can kind of provide the whole energy system, right? And so that includes charge infrastructure and the management of that, and the management of things like low carbon fuel standard credits. When it comes to vehicle to grid, I think we're still seeing a lot of regulations emerging there, and the value propositions. Certainly there have been a lot of interesting demonstrations, but to see that become economical, I think we're looking towards some of these interesting pilots and demonstrations that are being done across the country, to kind of drive the economic case. But I would say that today it's difficult for fleets to kind of factor those economics into their purchase decision, because it is a bit unknown, and some of the regulatory landscape about how it's going to all work is a little bit unknown. I think we all see that there's great potential there. And especially if you're a large fleet and you've got some real estate where you have depots, maybe around Los Angeles, for example, right? Well, you're probably located in some places where the grid needs some local support, right? And there's real value to the kind of ancillary grid services you can provide out of your depot locations, right? If it's done right. So we're kind of still waiting a little bit on the regulatory framework to kind of do that. So I would say we're certainly open to pilot and demonstration projects, but we haven't yet identified any commercial partners, and we know a lot of companies that are working on this. That we're happy to work with, and we'll kind of work with everyone who's trying to solve this problem, because I think it's going to take a lot of parallel threads.
Yeah, and of course it's always, with these items, it's not one partner will solve the solution, because you have, it's regional items, right? There's regional people who do it in certain places. So that's fair. Just curious, you talked about regulation a little bit. Do you see that regulation landscape is going to be changing in the near future? Because I know obviously New York, I think it's New York and California are typically the tip of the iceberg for those. What are some other states that you might see this coming in the near future? Just your thoughts, generally speaking, on the relationship between regulation and incentivizing the new innovation.
Yeah, so regulation's a driving factor now. I think the regulators have seen that electric trucks are possible, and so they want to create some momentum, right? They've been using the carrot a lot with incentives, and now we see the stick, right? So, the biggest, maybe one of the most important things to happen in the last year and a half in our industry was the Advanced Clean Trucks regulation from the California Air Resources Board, which mandates a certain percent of medium-duty trucks that are sold in California be electric. And that mandate begins in 2024, and the percentage increases to 75% in 2030, and I believe 100% in 2035. And this is just medium duty, but they have other percentages for the lighter end of that and for Class 8. And we've seen 14 other states sign an MOU, basically saying, New York included, saying that they are going to do something similar to this Advanced Clean Trucks regulation. And the California Air Resources Board has publicly indicated that they plan to issue a accompanying regulation that will put a mandate on the buy side as well as the sell side. So they'll mandate that fleets have and operate a certain percent of electric vehicles within the medium duty weight classes. And so, I think that those are going to be industry driving regulations. And I think their timing is right. I mean, they're pushing the envelope, but they're not regulating the impossible either, right? These vehicles are out there. And right now they're offering a lot of dollars of incentives for fleets that, want to try vehicles ahead of that regulation. But once the regulations kick in, the incentives will probably not be around as much. So good reason for fleets to, get smart about this now while there's money out there.
Yeah, I mean that's a good point to bring up. This is inevitable, and it's also the right thing to do. So why not get started? That's interesting. Yeah, regulation is a tough topic, because I know a lot of people are not a fan of the government telling people what to do, but at the same time, like, sometimes it takes that challenge, right? I think based off what you've said, it sounds like when people try these electric trucks, they're probably like instantly sold, or very, very quickly at least. I'm assuming a number of them have gone home and their next car purchase will be electric, likely, right? So I think that it's just a matter of like the adoption curve. People need to try things. People need to see that it's viable and then be okay with it, and just like put aside the old ways, right? I know not everybody's like us and wants the leading edge, right?
Yeah.
What are some of biggest challenges that you run into and maybe the biggest objections from clients?
Yeah. So, I think it's not an easy change for a lot of these fleets to go electric, and for good reason, right? Their vehicle is so kind of intertwined in their operations that even something like having to plug it in every night, can be a change. Um, and so I think, we see various objections to making sure the vehicle can do the job. Obviously, if they're driving 200 miles per day, electric isn't a good fit for them today. So that's one objection. The charge infrastructure is also a sticking point for a lot of fleets. We've tried to take our learnings and help fleets with that. Primarily we would like them to use electric trucks, and we'd like them to use our electric trucks, and so we'll help with the infrastructure and the charge stations and provide the whole system, because it makes it easier for them. And also it avoids one of the big after sales problems, which is the call that is, my truck isn't charging and I don't know why, right? Like, we want to avoid that, because the problem is the fleet doesn't really know who to call. Do they call the charge station provider or the vehicle provider? Because the charge station will say, well, all the other vehicles charge on our station, and the vehicle provider will say, our vehicle charges on all the other stations, right? And so they're kind of left to try and sort this out. And unfortunately, it does happen where we have these compatibility issues, despite everyone being compatible with the J1772 standard. It's not such an airtight standard that there aren't compatibility issues. And so, one piece of advice for fleets would be, either find someone who can kind of bring you the whole system, right? Then you have one person that's responsible, one company that's responsible for the whole system, or find a project manager who has done it before, who can integrate all the pieces of the system and will be around to support you after the system is deployed, because you don't want the project manager to evaporate and then you're left trying to figure out, which piece interfaces with which piece, because you've got vehicles, you've got charge stations, you've got the work with the utility, if you need utility upgrades. And so, we designed this quick start package now to make it easy, so fleets don't have to become experts in utility and infrastructure upgrades just to try a pilot. I make no promises that they're not going to have to learn a lot about energy if they want to convert their whole fleet to electric, right? But at least pilot and try these vehicles out, without necessarily having to do that. And so, infrastructure is kind of that other sticking point. And then, around the incentives, I'd say the incentives are really great for trying out vehicles, but a lot of the larger fleets would like to, go without the incentives, and allow the smaller fleets to have the incentives for pilots. And so, for them, that means leasing and kind of looking at the cost of capital and these, a payback period that is, maybe longer than what they're used to, but comes along with all these ancillary benefits, right? And so, kind of getting that economic model to work, and or finding and timing the right incentives, being part of the programs. In California, there's kind of a small window of time where you can actually apply for certain incentives, because it's first come, first serve. And, maybe they all get fully subscribed within the day that it opens. And so, if you decide you want an electric truck a week after that, well, you're going to have to wait if you want incentive dollars. So, timing the incentives is maybe the last one that I'd mention.
Yeah, I think that's a tough one. I mean, the idea of regulation, there can't be just free money for everybody, right? They need to have some caps on it, but there's so many people, right, who really could stand to benefit from it, and unfortunately, they have no clue what's going on, right? Because they don't have the infrastructure, the talent to track those changes. So that's interesting. By the way, do you have any partners or resources that people can typically track those major changes within the small to medium fleet sizes?
Yeah, so we we have a whole part of our sales and marketing team that focuses on incentives and tracking them and providing details there. But there's like CalStart is another nonprofit that does this. There's the Zero Emission Truck Initiative, ZETI, that kind of has a listing. If you search for that, you can find a listing of all the available electric trucks and information about infrastructure and incentives right there. So, but I think a lot of the manufacturers, like Motiv and others, we spend a lot of time and energy figuring out these incentive programs and helping fleets, holding their hands through it, providing packages that allow us to take the responsibility for the data collection and reporting that might be required from the infrastructure program, or sorry, incentive program. So I think reaching out to some of the vehicle manufacturers is another good way, to kind of jump into that knowledge stream. And obviously we're fully aligned with, conveying that information to all the fleets. We certainly want them all to know about the incentives. So, but CalSTART and others do that as well. Yeah. And you can always look at the California Air Resources Board website and the, hybrid and electric voucher incentive program. It's the big California one. Yeah.
Got it. Interesting. Very cool. Well, I guess just a couple other things here. What do you find the role? I've noticed that this is a theme with a lot of people I've talked to on here, is sometimes these new technologies, again, they're so new that typically universities are they're not a model that really changes their curriculum quickly per se. And there's a lack of talent coming out of universities that are interested in these spaces, have no idea these things exist. What do you see with the future of education potentially? And are there any things you are doing to partner with universities to try to help and encourage people to get degrees and to study in fields that will help them to be able to become innovators in this space in the future? Because I'm assuming the talent isn't always easy to find.
Yeah, I think we primarily have engineering in Bay Area, Silicon Valley of California, and also in the Detroit area, right? And our engineering base is kind of tech meets trucks, right? We pull from both of those pools. And when it comes to kind of training new engineers to be able to solve these problems, we've done some partnerships with universities. We're just launching another project next week with the University in Southern California, my alma mater, actually, Harvey Mudd College. And they train a lot of engineers in this field. Some of the Bay Area universities as well. My other alma mater, Stanford, and that other one across the Bay, whatever that one is, Berkeley, obviously. We like those schools too, and they train a lot of good engineers. I do think it's kind of interesting because the universities are seeing this kind of almost renewed interest in power and the power grid, and three-phase power engineering and power electronics. And where in the past maybe there was more of a focus on kind of chips and some of the low-level power, and things that are needed for cell phones and communications and all those skill sets we still need, obviously. But EVs have really unlocked this whole new kind of skill set of large, heavy power systems, right? Where we're talking in, kilowatts, not microwatts. And so it's an interesting engineering domain and discipline. And I think the universities are starting to kind of recognize this, and we're seeing more projects and programs, kind of geared towards kind of higher level power engineering that you would need. And obviously we still need a lot of the great automotive engineering in many of the schools in the Detroit area, and elsewhere, although there does seem to be a lot of talent in the Detroit area around some of the automotive skills. And the powertrain being electric doesn't change the need for many of those skills, right around the chassis engineering. So that's still a major skill set for electric vehicles. So I'm pretty encouraged to see some of the new programs and new ideas that are coming out of academia. And I think when you kind of combine those with startups that are working on electrification, and even what some of the larger companies are doing and trying to do, I think all of these different kind of stakeholders and participants see that there's a lot to be done here, right? And so it's a pretty exciting time in that regard.
Yeah, that is interesting. I'm always encouraged to hear that, because I think that it's very important to think about the next wave of what's coming, right? And I think that obviously there's probably a smaller number of people doing what you're doing in the space, and as that increases, which we obviously need, right, there's going to be a big vacuum that's created with the talent needs, and at that point it becomes even beyond this. This is a topic I love, is the idea of retaining talent too. So I think that then it's like, now you're the expert and now people are going to want to take from your group of people. So how can you retain that and everything? But that's maybe a different podcast.
It's a real, just to speak to that though, I mean, it is like, certainly, I'm quite proud when we bring in a new college grad and they learn all about electric vehicles and electrical engineering, or whatever their field is, and then in a few years, they're now professionally developed to a place, and they go and we seed talent into other companies. Like I don't think that that's a bad thing, and I don't mind being part of that ecosystem. I think our primary mode of both attracting and retaining talent is the mission-driven nature of what we do at Motiv, right? If you're passionate about freeing fleets from fossil fuel, then Motiv's going to be a great place for you. You're going to love it here, right? If you're not interested in that vision of the future, right, you're going to find Motiv to be a frustrating place. But that's one of the most fun things. Like I don't come into the office as much as I used to in the last year, right? Unfortunately, but I love being around our team because you just feel that energy, and I think that that's why people come here, right? Because we find that a lot of people really do. They've got one career at a time to have, right? And they want to put it somewhere they care about. Yeah.
Exactly. Yeah. That's something I've definitely noticed in a lot of, especially young people, is there has to be more than just the dollars and cents of the job. So one last thing that came up in that discussion of education was when a company electrifies their entire fleet, what is because I know there's obviously a lot of these fleets probably have in-house mechanics to handle stuff. What does that transition look like? Are they able to be educated to just kind of change roles? I know it's obviously very different, mechanical versus electrical. So what does that look like?
Yeah, it can be a bit of a change, right? Because generally electric vehicles require a lot less service. And so these service technicians that have done oil changes and, transmission, jobs or whatever, they're now faced with kind of a little bit of a challenge, right? And we've seen differing reactions to this. I would say the most common reaction we see is the technicians are excited. They're excited to learn a new skill set, and they're excited to not have to deal with oil and other fluids and kind of the greasy bits as much, right? And they kind of recognize that they have an opportunity to develop a skill set that's going to be a lot more focused on vehicle diagnostics using software tools and vehicle configurations and like adjusting the way that the vehicle is performing and and looking into diagnosing problems or configuring systems around when the vehicle charges, how the vehicle charges, right? And becoming more of like this energy system administrator rather than kind of oil changer. And I think we've certainly seen that many techs like that. Some techs don't like that. They're not as interested in that. And electric vehicles pose a challenge there because they don't have as many greasy bits. They don't have as many moving parts. The maintenance schedules are dramatically reduced. And so I think that there's this shift, but it doesn't mean that there's not good, interesting work to be done when you think about the kind of service maintenance and kind of, maybe to use the word, administration of these vehicles, right? It's just kind of a different skill set, but we find that obviously that like a lot of those service techs have the right intuition. And when it comes to diagnosing problems, once they learn how to use the software tools, they're still using that same intuition that they used maybe in a more mechanical sense before.
Yeah, I mean, that's actually interesting you bring that up because I would assume that a lot of people are probably seeing this transition happen, right? I have two uncles who are mechanics, right? And the electrical side of things typically escapes them, right? But if they had an opportunity where they're in their current job and they have the ability to be upskilled into a new set of technology, that's going to make their career much more steady. They're probably going to have a lot more stability going forward because of that new skill set. So that's interesting. I didn't think about that. Yeah, well, this was great. I really appreciate you coming on. Where can people reach you?
Well, Silas, the best way is probably via email. It's just my first name, Jim, at MotivPS, MOTIVPS, it's in powersystems.com. So that's probably the easiest. And yeah, I would look forward to hearing from people who are interested in electrification. And really appreciate you spending some time on the subject and having me here with you.
Yeah, absolutely. It's been a pleasure. And I always find that I come out of these discussions so energized and learning so much. So I really appreciate you taking the time, and we'll see you next time on the podcast.
Great. Thanks, Silas. Have a good one.
Thanks so much for joining on today's episode of CleanTechies, the podcast. I really hope you enjoyed the content we talked about, enjoyed the conversation with Jim. I found a lot of value out of it. I always do on these conversations. Typically, it's the end of the day when I record these, and I'm always pretty exhausted, but after I come out of these conversations, I'm just so pumped up for the new technologies I learned about. So I hope you found that interesting as well. Please do, if you found out about this through social media or if you're watching on YouTube, share your thoughts. I'm always very curious to hear any questions you have or things maybe I missed, just ways to improve the podcast that we can help people to understand kind of what it is that they're looking to know, because obviously I have the opportunity to speak with these individuals. So very glad to pass along any important questions. Please, you can reach out to me. There are various ways. I'd say probably the easiest way would be through Twitter at Silas Maynor, or you can join my Slack channel, the CleanTechies Slack channel, and you can reach out to me there. Also, as mentioned earlier, please do share with any friends or maybe business owners who could particularly find this technology useful. I think it's a great way to help kind of share the knowledge in a very practical way that can be very helpful for implementation. Of course, also subscribe to the newsletter that comes out every month on the 27th. This month we will be sending out the newsletter, and the topic is air quality and some companies that are looking to help track and improve air quality, not only on a broader scale but also in more individual areas. And then, of course, as mentioned, please do join the Slack channel. It's a great way to meet with other professionals. We're growing it very slowly, but looking for anybody who's interested in the space to join and be part of it so they can continue to learn and network with other individuals in the space. And then if you are interested in supporting the show, you can go to the Buy Me a Coffee link in the description, similar to Patreon, if you wanted to support the show directly. But with that, thank you again so much for joining us on today's episode, and we will see you next time on CleanTechies, the podcast.